transfer your power from one end to the other end with the help of your gates or maybe your gate trains. So now when you go with the belt drives, you do not have your exact contact. That was generally we say it as a non-flexible one. This we generally say it as a flexible one. So here there is no usually contact between those two. And when your power transmission is large enough, the distance between those two is large enough, if you want to still transfer your power, then you'll go with the flexible drives that are chain, either maybe a belt, either maybe a rope drives. So in this of your flexible drives, which you have your belt drive, chain drives and rope drives, only belt drives is a part of your syllabus. Chain and rope drives are not a part of your syllabus. So we'll be discussing only about the belt drives. So in this, let us first learn about the flexible drives, their advantages. Then we'll move on to the belt drives one. So in the flexible drives, if you go through over here, there is an intermediate link such as belt, rope or chain. In between there is an intermediate link. Suppose if you go with the gear drives over here, there is an intermediate gear, but there is no effect on the case of your drives, maybe in a speed or a velocity ratio. But when you go with the ropes over here, when you have your ropes transferring from one end to the other end, you can have your effect on the case of your belts as well as your rope or maybe a chain drives. So that is the major advantage or maybe a disadvantage put together. Both you have advantages, disadvantages. We'll learn what are the advantages and what are the disadvantages also. So in case of your gear drives, the rotary motion of your driving shaft has been transferred onto the rotatory motion of your driven shaft by means of a pinion and gear. Suppose if you go with the gear drives of your gate train, maybe riveted or anything, in between you have your pinion and maybe in a gates or maybe in a what you call automobile gear boxes, anything you have a pinion or maybe a small gear or maybe a planetary gear or maybe a sun gear. With the help of these planetary gears itself, you have a translation of your motion from one to the other one. So in case of your flexible drives, that is a non-flexible drives. In case of your flexible drives, the rotary motion of your driving shaft is first converted into translatory motion of your belt or chain, and then again converted into rotary motion of the driven shaft. So here you have your one end, the belt which has been fixed. Here you have shaft, you have another shaft over here. So in between there is a connection of your belt. So in between the belt there is an intermediate chain points. So when there is an intermediate points in between, if you want to transfer your rotary motion into rotary motion, one form of the conversion to the other one, first it is usually done with the help of your belt, and again it is converted by the motion onto the driven shaft one. That is intermediately there is a link in between. So transfer of motion, there is a time lag in between for your flexible drives. That is not the case of your non-flexible drives. So this was about your flexible drives in the first one. Next, if you move on to the advantages and disadvantages of your flexible drives. So first we'll start with the advantages of your belt drives, because whatever the points now I'm discussing and I'm telling you over here, it will be asked straight away in your exam. Such a way like the point like what are the advantages and disadvantages of flexible drive, what are advantages of belt drives over what you call gear drives, what are the disadvantages of belt drives over gear drives. All the points which I am making you aware now in this class will be directly asked in the exam. So please pay attention and listen carefully, and after that also I'll post all this PPT and videos. You can go through a number of times if you still have any kind of doubt, and if you have it is still not clarified, you can post me a message also. I'll still try to clarify over there. So advantages of belt drives, if you go through, this is a flexible drive which transmit power over a comparatively long distance due to an intermediate link between a driving and driven members. So first of all, why you are choosing a belt drive is if you want to transfer your power from a long distance. That is a major advantage. That is the point which is listed the first one. Since there is an intermediate link is long and flexible, it absorbs shocks and damps and vibrations. This is a very important point to be noted, which that not the case of the gear drives. Because in case of your gear drives, you have only a small intermediate link, that too with a short distance. In that also, these intermediate gates do not have any effect. which doesn't absorb the shock loads or vibration. But the case of your belt drives, in between, if you have one belt over here, another belt over here, which has been joined in between intermediate links, if there is any kind of vibrations or shocks which is being given by the belt, which is absorbed by the intermediate links, that is a very good advantage when you go with the flexible drives. That may be either belts or chains or maybe a ropes, anything. And next advantage is flexible drives provide considerably flexibility in the location of driving and driven shaft. The tolerance of the center distance are not critical as compared with the gate drive. So what is the major point over here is the tolerance. Tolerance means such a way like whatever, if you are trying to get a product of that, is that product which you are getting with 100% accuracy. It is not possible at all in a nature practically. So whatever extent you are trying to reach to that product maximum with an efficiency, that is, we say it as a tolerance, which we give plus or minus. So if you want with an efficiency of 100% theoretically, you may get 98, 96, which is in related to that. That is generally we say it as a tolerance. So with this flexible drives, the location of your driving and driven shaft with the tolerance of your center distance is not so critical, but that is the critical in case of your gear drives, because variation of your center distance, by that you have your variation of your what do you call flexibility, or maybe your power transmission, or maybe efficiency, any of the parameter. So that's not the case in case of your belt drives. Next, belt drives, or maybe rope, or maybe the case of your chain drives, which are very cheap and easily available, but not that the case of your gates or maybe a gators, because manufacturing the product of the gears itself is a bit complicated as well as costly, and also the maintenance cost of the gears or maybe a gear drives or gear trains is much more, because it requires continuously lubrication process and all. So that's not the case in case of your belt drives. That is one of the good advantages which you have in case of your belt drives or maybe a flexible drives. And the only disadvantage which you have the case of your belt drives is it occupies space. That's not the case in case of your gate drives. That is the case if the space is not a constraint, then you'll go with the gate drives itself. And the velocity ratio is very small. First of all, what is a velocity ratio? Is nothing but your driving member, which you have the speed to the ratio of your driven member. So here the speed of your driving to driven is, you have your velocity ratio high when your driving member speed is higher, but it's not the case in case of your belt drives, because the power will be equally distributed. The driving and driven member will be almost runs with equal speed. That's the case. Your velocity ratios are very small in case of your belt drives, but it's not the case in case of your gear drives. And next, velocity ratio is not at all a constant. It will vary. In that case, if you are making the motion of your transferring power in an axis exactly parallel to that, if you have your gear in a mesh, then continuously you have your velocity ratio as constant, but that's not the case in case of your flexible drives or maybe chain or belt or maybe anything. So these are about the advantages and disadvantages of belt drives. Next, we move on to the other topic, that is the same which you have learned previously was for your flexible drives. Flexible drives is including your belts and chains. So now let's focus on the major topic which you have in your syllabus is belt drives. So belts are usually used to transmit the power from one end to other end, which you have very long distance of your transmission, which it is basically done by two shaft by means of your friction. You have one shaft over here, other shaft over here. This shaft is rotating a driving member. This shaft is rotating is a driven member or the follower one, which we say is. The belt is attached to the shaft and belt is also attached to this shaft. You have different kinds of shapes of your belts. I will go through one by one. So in that, when your belts are being placed with those two shafts in a line, then due to the friction which is arising, because this belt is in contact with your another one shaft, due to the friction which is arising, the power will be transmitted from one end to the other one. So in this you have three elements: driven and pulley. Is the same one, which is you have the same case of your gauge, but here you have more intermediate points when you compare with the gauge race one. So that is about the simple definition of your belts. Suppose if this is a question being asked in your exam for short answer one, what is a belts? Then in this way you need to define the belts. Next, if they ask you advantages, what are the advantages of your belt drives? The same points which the case of your flexible drives, you can also list out those same points. Belt drives can transmit the power from one considerable distance between the axis of driving and the driving shaft, which is you can transmit for your long distance, anything. The operation of belt drive is smooth and silent, where the case of your gears, it is a bit noisy because both gears are in mesh. So when it is in mesh, when you have your contact, obviously your noise is a major problem, but it's not the case in case of your belts. Of course there will be some kinds of noise, but considerably less when you compare with your case of the gears. Next, they can only transmit a definite load, which is if it exceed will cause the belt to slip. That is a major problem. So we'll go through what is a slip, what is the advantage with slip, what is the disadvantage, which is already we have learned in the case of your reciprocating pump. In a similar case of your reciprocating pump, you also have a slip in case of belts, which I have mentioned the point over here. That we'll go through and we'll learn what is a slip. So they also have the major important advantages: ability to observe the raw shocks and vibrations or anything which is being absorbed by the intermediate links in between. So this is very simple to design. In the case of your gears, you know, you have your spur gear, helical gear, or maybe different gears. The design is very complicated over there. In a small space we need to fit. That is a major disadvantage. So here that's not the case. And next, they have low limit cost. The cost initial is very low, but the case of that the fabrication or some maybe the production or the cost is very high in case of the belt, what do you call gears one. Okay, so now let's move on to the other one, disadvantages and applications. Obviously for everything there is a pros and cons. Till now we have learned about the advantages. Now we'll be learning the disadvantages and applications. So usually if you list out the disadvantages, which I earlier told was velocity ratio, which is not constant, as well as the velocity ratio is low, and space occupying is a major problem. What are the disadvantages which you are listed in case of your flexible drives, is also you can list out over here. They can impose heavy loads on shafts and bearings because the contact which you are going to have continuously and number of intermediate links which is coming in between, that makes a little heavy load on the shafts and bearings, and there is some kind of loss in between resulting in a low efficiency. The efficiency of your belt drives is quite a bit low when you compare it with the efficiency of your gear drives, because that is more in contact and the transmission is smooth and more power. But case in this, you have your intermediate links obviously transferring from one end to the other end. It takes time lag, as well as the power loss maybe due to different friction or maybe other important points. So in that, when your power loss is there, obviously your efficiency will come down. And obviously major important thing is service or maybe a life. Continuously you are having a contact of that, obviously your life of your belt drives will be low, as well as when you go with that your life of the gear drives will be higher enough. And next, applications, belt drives are mainly used in electrical motors and automobiles and machine tools, and belts conveyors in the power plants, where you go with the coal mine areas where you have your transmission or transferring of the products, the coal, which is usually done in the belts and conveyors. That is about the disadvantages and applications. Next, we will move on to the other one, definition of your belts and types of belts. They ask you for short answer one, define belts. In that way you can go through the definitions, like the belts or ropes are used to transfer the power from one shaft to another by means of pulley which rotate at same speed or at different speed. That is a simple definition of belts or maybe ropes. So in this you do not have a ropes, so usually you go with the belts, so do not worry about the ropes and all. So belts are used to transfer the power from one end to other, which rotate at the same speed or a different speed. So you have different types of belts. One is flat belt, a V belt, circular belt, or rope. So in this part of your syllabus of 3 belts which you have, only flat belt is a part of your syllabus. You do not have V belt, you do not have circular belt or ropes. So you're lucky enough, because for the mechanical engineers at a bit lengthy syllabus they have. So in that case they usually need to learn about the V belts, circular belts, and ropes also. So question arises like, what is the use of the belts which we are learning in electrical subject? The major answer to that is such a way, like sometimes you may work in an automobile industry in the future because everything is turning into the electrical one, or you may work in electrical power stations, or somewhere you may work in an industry. Anything, if you want to transfer the power from one end to the other end, suppose if you work in hydroelectric power plants, if you are dealing with the transfer of the power, water lifting, and then allowing it to move on, there you have different pumps. In that case, the pumps which is usually transferring the power is also done with the help of your belts itself. So also if you go with the steam power plants, in the thermal power plants also, you have reciprocating pump, which is you have high flow rate. In that case also, it is you have your transferring power from one end to the other end with the help of your belts. So there are a lot of applications which you come across in your triple E in your electrical department also. That's the case. This topic has been included in EMA to learn for the basics. Okay. So now we'll go through the small definition which is related to the flat belt, V belt, and circular belt. Flat belt is mostly used in factories and workspaces, and moderate amount of power is to be transmitted from one pulley to the another, whereas about 8 meters apart. If there is a distance of 8 meters apart, then you'll be going with the flat belts. Again, in a flat belt, you have different types. One is open belt, cross belt, and all those things. So this is a part of your syllabus, the flat belt, open and cross belt, that will go through one after the another. And there is a lot of derivations which is related to the open belt and the cross belt, calculation of length, the power transmission, velocity ratio. All those I will make a separate video which is related to the derivation. And next you have your V belt. This V belt is mostly used in factories and workspaces, same, where the moderate amount of power to be transmitted one pulley to another, where two pulleys are very near to each other. When you are two pulleys are very near to each other, then you will be going with the V belt. And next you have your circular belt or rope, which is mostly used in same factories or maybe any other applications where it is power transmission. If it is more than 8 meters, then you'll be going with a circular belt. Okay. So leave about the part of your V belts and circular belts. Only the flat belt, which is a part of your syllabus, will be going through in detail about the flat belts. Okay. Next, moving on to the another one. After this, the materials which is used for the belts. So coming to the materials, you have the leather belts, cotton, fabric, or rubber belts, or balata belts, which most of the cases, the belts which we generally use is the balata belts. Sometimes once the question been asked in your exam about the leather belts, what the materials which is used for the belts. So in that case, that's the case I have listed the materials which is used and what are the types of the belts which we have. So here the most important belt is the leather one, which is if it is made from your belt from 1.2 meter to 1.5 meter long strips cut from either side the backbone or to the top grades. That is about the case of your leather belts. There is in detail more about that, but I have not listed. So and next you have your cotton, fabric, or maybe a rubber blends. Most commonly in all the applications, we generally go with the balata belts as well as the rubber belts, which because you know it has more life as well as the strength. That's the case. You go with these two belts. I'm not going much in detail about the materials of the belts. I'll move on to the next one. That is the flat belts. So coming to this is a part of your syllabus, the flat belts. So in this flat belts, which I already told you, you have two types, open and cross belt, that will go through one after the other. We'll discuss first the advantages of the flat belts over the other types and disadvantages, and then we'll go through the types of your open and cross one by one. So here flat belts are narrow rectangular cross section, while V belts have a trapezoidal cross section one. So these flat belts has major advantages. One by one we'll go through. First advantage is like it can be used by a clutch by making a simple provision of shifting the belt from tight to loose pulley, vice versa. Such a way like if you have your automobiles device one where you have your engaging or disengaging one. In case of that clutches or maybe an automobiles which you have, this usually the flat belts is used where you have your what do you call when you actually have a cooling system which has been present over there. For this cooling system you have a radiator over there. This water which is present in the radiator, which collects the heat from your automobile and it allows to move on to the atmosphere. In order to have your faster cooling, you have your fan which has been placed over there. These fan, which is usually driven by a belt, that is maybe a V belt or maybe a flat belt. Okay, so next is we have a different velocity ratios which can be obtained using a stepped pulley. If you have one after the other stepped pulley, you have your velocity ratios variation, which has been done from one to the other one. And this can also be used in a dusty abrasive atmosphere, which is one of the good thing. And this can be used for longer center distance, even up to 15 meter. And the efficiency of your flat belt is greater than your V belts. So this is about your V belts, flat belts, which you have your advantages over your V belts. And next, we will move on to the another one. You also have some disadvantages of your flat belts over the V belts that we are going to list out, because sometimes with the question being asked what are the advantages and what are the disadvantages of your flat belts over the V belts. So in that you need to list out all these points. The power transmission capacity of your flat belt drive is low, and the case of your V belt is higher. Usually, how do you calculate your power? Is usually it depends upon your what do you call tension as well as your velocity. Tension in the sense, when you have your tightening of your tight side and slack side, variation of your tensions due to your variation of your torque, all those things, you have your T1 and T2. So power can be calculated with the help of this both tensions on the tight and slack sides. When you have your belt which has been what do you call in contact with the driving and the driving member, if you make this tight, this will be loose enough, and if you make the tight on the what do you call a driven member, then driving member will be loose. So in that variation of your tensions on both the belts, you have your power transmission, which is T1 minus T2 into V. So in case of your V belts, you have more contacts. As a case, you have your more power transmission than the case of your flat belts. And next is velocity ratio of your flat belts is lower. Obviously, if your velocity ratio is lower, your power transmission is also lower. And flat belt drives have larger dimensions and occupies more space when you compare with the V belts. V belts, flat belts is a rectangular shape one, where wheel belts is such a way like you have some angularity, which you have your contact, which can be made provision in your smaller space also, where that's not the case in case of your flat belts one. Flat belts generate more noise than your V belts, because the distance among that is larger enough. In V belts is a compact one, so noise is less. So flat belt drives are horizontal and not vertical. It is only in this direction, where in the V belts you have your horizontal as well as both the or vertical also. So that is a major disadvantage of your flat belt drives when you move on to the V belt drives. So what are the applications of flat belts? Flat belts are used on belt conveyors, automobiles, and clay machineries, crushers, sawmills, textile machinery, belt elevators, anywhere. There is lot many applications of your flat belts. Okay. So let's move on to the next one type of flat belts, which you have: open, cross, turn belts, belt drive with idler pulley, compound, stepped, or maybe fast and loosened pulley. So out of this all, you have only two types in your syllabus, which is open belt drive and cross or maybe twist belt drive. Quarter belt drive with idler pulley, compound, stepped one, fast, which is not a part of your syllabus, so do not worry. So you're lucky enough to have only these two, which is major important one. So these two will learn in detail, open and cross belt drive. So first we'll move on to open belt drive. So coming to the open belt drive is used with your shafts arranged parallel and rotating in the same direction. So in this case, you have your driver which pulls the belts from one side, which I already told. This is your driving shaft one member, driven shaft member, which pulls from the other one side and delivers it to the other side. So if this is your lower one, this will be your upper one. If this is your upper one, this will be your lower one. So that the tension in the lower side belt will be more than the upper side one. When you pull this, the tension on the lower one will be more than the upper one. So the lower side belt, because of more tension, is known as tight side if you have more tension, and whereas the upper side belt, because of less tension, we generally see it as slack side. So this is tight side, this is a slack side. So an open belt drive is a belt drive in which belt proceeds from top of one pulley to the top of another without crossing. without crossing, it moves on from top to the bottom one. So that is about your open belts. And in open belts where the center distance is more in between, you have your X center distance. Due to that, you have your pitch and all those things that we'll learn later in case of derivations. So vibrations in your direction, perpendicular direction of motion, when the center distance is small, the belt slip increases. So what is a belt slip? That we'll learn in the next slide. So this is about your open belts. So we'll also derive about the length of the calculation for your belt. What should be the length of the belt in the derivation in another class. So next is the cross belts. Cross belt is a belt in which the belt proceeds from one top to the another pulley to the bottom one, and another crosses over itself, where in case of previous one, where it doesn't cross the other one, where it moves from to the bottom one. Hello? Any doubts? Hello? Guys, shall we proceed? Any doubts still here? Right. Right. So in a cross belt drive, the driving and driven pulley rotates in opposite direction, where in the case of your open belt, it proceeds on the same direction. The only difference between your cross belt and the open belt is like the direction which is opposite to that. And when you have an shifting of your top to the bottom one, which also crosses itself and it shifts to the lower one. That's not the case in case of your open belt one. So in cross belt, the angle of wrap is more. So what is the angle of wrap that we learn in case of your derivation? Theta, how to calculate the angle of wrap, that will derive in a derivation in another class. So therefore, with this, the power transmission capacity for the cross belt drive is more than the case of your open belt drive, because if your angle of wrap is more, then your power transmission is more. So how? That's all based on the derivation relations that we'll try to calculate. So in the cross belt drive, the belt rubs against itself because it is crossing each other, but it's not the case in case of your open belts. So that is a major difference between your cross belt and the open belt one. And next is V belts. V belts is not a part of your syllabus, but even then I have listed out here. Sometimes who knows, an examiner, if they ask without going through the syllabus part, there is a case I have listed the V belts advantages and disadvantages over the flat belts. You can go through where V belts are usually used when your distance between those two is very short, and it permits higher speed, and it has more velocity ratio, it has more power transmission, and the efficiency also will be higher. And the drive is positive because the slip is negative, as which I have learned the slip to be positive and negative, where here if your slip is negative due to the wedge action, the theta angle in between that, the drive is positive over here. And V belt can operate in any position, which is vertical, horizontal, anything. But the case of your flat belts, you have only direction and a horizontal, not in a vertical. So that is the advantages of your V belts over flat belts. You also have few disadvantages of V belts over the flat belts. That's like the cross sectional height of the pulley diameter is large in case of your V belts, because along with the pulley itself, the V belts usually transmit. So in that case, your height of the pulleys which you have, your case of your V belt is higher enough. So these will increase your bending stresses in the belt, and which will also affect the durability, and the life of the belts also will come down. And with this, the efficiency of your V belt is lower sometimes. In your flat belt, the major important one is creep is the higher in case of your what you call V belt than your flat belts. So what is a creep and all those things we'll learn in the next topic. Okay, so this is about your disadvantages of V belts over a flat belts. And next we move on to the applications. V belts are very popular, which is used in all electrical motors, prime movers. So right now, which you go via centrifugal pumps or maybe reciprocating pumps, all those kinds of applications comes under the V belts, fans, pulleys, which is pumps, all those things which comes under the applications of V belts itself. So what is a velocity ratio, and what is the velocity ratio for each belts, which I have listed over here? This is very important one, which will be expected for short answer question. So V belts, velocity ratio is nothing but the ratio between your velocity of your driver and the follower or maybe a driven one, which I already told you velocity ratio. If your driver is N1 and your driven is N2, N1 by N2 is nothing but your velocity ratio. And here the velocity ratio for your flat belts is given as 4.1. And the case of your V belts velocity ratio is 7.1 and chain drives is 15.1. 15 is to 1. The chain drives velocity ratio is higher. It's not a part of it, so do not worry about that. That's the case when you have your more velocity ratio, more positive drive, and that is the case. It is mostly used in case of your transmission in your motorcycles and your bicycles and all, where you have your smooth transmission of power. Okay, so that is about the applications and velocity ratio of your belts. Next, we move on to the another important topic is slip and creep. Most expected question in case of your short answer question. The last slide in today's class about your belts is slip and creep. So what is your slip and what is a creep? Slip, which is already we have learned in your reciprocating pump. If you just recall that slip in case of reciprocating pumps is like you have your coefficient of discharge both is difference of your coefficient of discharge or maybe difference of your what do you call actual to the theoretical one, which you have your rate of flow actual one which is practical case and theoretical one q ALN by 60. So difference of those two gives you a slip. So slip will be usually negative and positive. So in case of your slip is negative when you have your actual which is less then the case of your theoretical one. Sometimes sorry, it is positive. And sometimes if your actual will be greater than your theoretical one, then your slip will be negative. So that's the case if your slip gets negative when you have your direct contact of your allowing your water to lift and continuously flow. That's the case of your reciprocating pump. So usually the slip cannot be zero, it will be either positive or negative. Most of the cases and practically it will be positive slip. In very rare cases you get a negative slip. But negative slip is a good sign for your reciprocating pumps which you have over there. So similarly in case of your belts also you have your slip which is positive and negative. So let us try to understand over here. The frictional grip which you have between your belts which is in contact with your shaft which becomes sometimes insufficient. This may cause some forward motion of the driver without carrying the belt with it. So sometimes if you observe in any kind of machine when you make your belt which is in contact with the other one, you can also observe in some kinds of machines nearby your homes also. Generally we say it as well the Girni machines, all those things which you have. In that you have your belts fixed like flat belt and cross belt, so open belt and cross belt. So you go with some kind of meshing to have with open belts, and sometimes you go with the cross belts one where your distance between those two is large enough. If you want more higher speed to be done within a short time, then you'll go with the cross belts one. So in that, when your grip between that is insufficient, it moves forward and it slips the driver which you have the shaft of the driver one which do not carry its belt. It slips and it moves away. This may cause some forward motion of your belt without carrying the driven pulley. This is called slip of the belt, which is expressed in terms of percentage. The actual 1 to the theoretical by actual into 100%, which is generally we say it as in terms of slip. So this slip usually takes place in case of belts. So here we need to avoid the slip to take place. When there is a slip, obviously there is a power loss, efficiency comes down. So in order to avoid the slips, we generally go with the additional intermediate connections in between to have continuous contact between them. All those things are there, which I am not going in detail, which is not so required for your electrical department also. So that is about the case of the belt slip, which you have your positive and negative. When you have usually you will be having a positive slip because most of the cases you generally have your contact which is less makes you slipping. That's the case you have your positive one. Very rare cases you'll be having a negative one. And next you have creep. What is a creep is like when the belt passes from the slack side, you have, which I told you earlier was slack side and tight side for the lower one and for the higher one. So when the belt passes from your slack side to the tight side, a certain portion of the belt extends and it converts again when the belt passes from your tight side to the slack side. So these, due to this changes of length sometimes increases, sometimes decreases. So due to this changes of length, there is a relative motion between the belt and the pulley surfaces. These relative motion is expressed in creep. express in one definition, which is nothing but we say it as creep. So total effect of creep is to reduce slightly the speed of a driven pulley or maybe a follower. So usually the speed creep is usually expressed in terms of your speed or given by the velocity ratio, which is nothing but n2 by n1 is equal to d1 by d2 into E plus under root of sigma 2 by E plus under root of sigma 1, where sigma 1 and sigma 2 are stresses in the belts of your tight side and slack side, and E is nothing but Young's modulus of the material of the belt, which will be directly given in a problem. So sometimes if they ask you to calculate what is the slip, if there is this much of slip, what is the velocity ratio, all those things, the problems, I will solve it in a separate numerical sessions of the video session. Okay, so this is about the creep. So that's it about the video session for today's class, the topic which is related to theory of belts. So I'll stop it over here. I'll take a separate video session, the recorded one related to the derivations related to belts and problems, numericals related to the belts. I'll solve on and about 10 numerical problems related to that with the different models. With that help, you need to solve the 10 models problems which has been already asked in your OU previous year questions. So hope that problems will make you to sufficiently solve the numericals which is related to the any question being asked in the exam. So about this, now we'll go through the topic of your previous year questions which has been asked in your OU exam, which is related to the belt drives. Let us first read out the theory questions which has been asked over here. Here the question is sketch the compound belt drive and write its applications. Just before whatever we have learned the belt drives, which is a compound, is nothing but the combination of that, which you have more advantages is such a like you can have more power transmission, larger distances which you can have transmission of your power, and smooth one, efficiency will be higher, power will be higher. In so many ways you can extend your advantages. And next you have velocity ratio, the compound gear, and slip of it. What is the velocity ratio? Ratio of your driven to the driven one, and slip is nothing but which you have your contact which you are making your belt to move away from your driven member is nothing but we say it as a slip. So define creep and slip just before we have gone through the definition. Next is write the advantages of V belts as compared to flat belts just before we have discussed, and derive the expression for length of cross belt. This I'll do it in a separate session, the derivation. Then what is the condition? This is also a derivation part, I'll do it. And what is the effect of centrifugal tension? This is also derivation, I will do it. Next, compare belt drives and gear drives. In the first slide itself, I have gone through what are the applications of belt drive, which is already I have given you many applications. So this is about the short answer questions which has been asked. And next we move on to the long answer question. Derive the expression for length, which is already told you. I'll take a separate session for the derivation, lengths of open belt and cross belt. Next, write a short notes on compound belt drive just before we have gone through. Next, the condition of maximum power transmission, which I told you, derivation you'll go through. Expression of limiting tension, again a derivation. And write a short note on belt material just before we are gone through balata material, rubber one, and all those material, leather belts. In that case, you can list out all these materials, which is already we have gone through the slide. So with this, I'll stop. And there is no more numerical problems which is related to the belt drives. I'll solve on and about 10 models in this case by making another video. With that models, you should try to calculate all the problems which is related to the questions being asked in the final exam. So with this, I'll